Hello dear, today I am going to discuss existence of limit and continuity of a function at some point. At first we discuss existence of limit. Existence of limit. Any function like that, limit x tends to a fx be exist at this point x tends to a if it will exist left hand limit and right hand limit. What is left hand limit? Suppose that a is the point. If we go left side, then something minus, and we go right side, then something plus. Here left hand limit sense is limit h tends to 0 f of a minus h, or we can also write f of a minus 0. And right hand limit is limit h tends to 0 f of a plus h, or f of a minus a plus 0. So any function left hand limit equal to right hand limit, then f of x limit x tends to a exist. That means limit h tends to 0 f of a minus h equal to limit h tends to 0 f of a plus h, and value of this limit will be this value. This equal to limit x tends to a f of x, and like that some value l. Here if left hand limit equal to right hand limit, then this function exists at this point, limit x tends to a. With example we can discuss the existence of limit x tends to 2 x squared minus 4 by x minus 2. Here f of x is x squared minus 4 by x minus 2, and we simplify it, then we get x minus 2 x plus 2 by x minus 2. Here x squared minus 2 squared, so it will be a square minus b square, a minus b into a plus b divided by x minus 2. This term cancel, and f of x is x plus 2. Now at x barabar 2, left hand limit h tends to 0 f of 2 minus h, then we get limit h tends to 0 2 minus h plus 2. Here f of x is x plus 2, so f of 2 minus h is 2 minus h plus 2. So we get limit h tending 0 4 minus h, and this equal to 4. Now right hand limit h tends to 0 f of 2 plus h, and this equal to limit h tends to 0, and now here f of x is x plus 2, so f of 2 plus h is 2 plus h plus 2, and we get 4 plus h, value is 4. Here left hand limit equal to right hand limit, and this equal to 4. That means this function at this point exists, and its value will be 4. Hence fx limit fx exists, that is limit x tends to 2, x square minus 4 by x minus 2 exists and its value is 4. Now next question we discuss the existence of limit x tends to 0 mod x by x. Here fx is mod x by x. We have to discuss at point 0. At x barabar 0. Now left hand limit h tending 0 f of 0 minus h. So here limit h tending 0 mod x by x, so this will be mod f 0 minus h divided by 0 minus h. Limit h tending 0, if we take any number from mod we get positive, so this will be h by minus h and value is minus 1. Right hand limit h tending 0 f of 0 plus h, limit h tending 0 mod of 0 plus h by 0 plus h. This will be h by h and value is 1. Here left hand limit not equal to right hand limit, so f of x does not exist in the sense of limit x tends to 0 mod x by x does not exist. Also we can write left hand limit. Here I have written limit as tending 0 f of a minus h f of a minus 0, or we can also write this limit x tends to a minus f of x, or here limit x tends to a plus f of x. So this is the problem, this is the method how can we check the existence of limit. So we have to find left hand limit and right hand limit. Both value be same, then any function given point we exist and its value will be the left hand limit and right hand limit value. Now we can discuss the continuity of a function at some points. Continuity at a point. For this we have at first find left hand limit, right hand limit, and at some point, at given point, all the value be same, then any function be continuous at given point. Suppose that with an example we can easily show. Discuss the continuity. Discuss the continuity f of x equal to x square sine 1 by x 0. Here condition x not equal to 0 and x equal to 0. We have to check at x barabar 0. Here given point is 0 at x equal to 0. At first we have to find the value of left hand limit. Limit h tending 0 f of 0 minus h. For this function, which function, given function, we adjust. At first we have to check which function adjust for this value. 0 minus h, that means x is not equal to 0. So f of x equal to x square sine 1 by x adjust. We take limit h tending 0 for x 0 minus h square sine 1 by 0 minus h. Limit h tending 0 h square sine minus 1 by h. Limit h square minus sine 1 by h. Here sine minus theta is minus sine theta, so we take here minus h square sine 1 by h, and this value will be 0. But how? Here h is 0, but sine x equal to minus 1 to plus 1. Here x belongs to r. So sine 1 by h will be any finite value, but h is 0. So 0 into something is 0. Now right hand limit h tending 0 f of 0 plus h. Limit h tending 0 plus h square sine 1 by 0 plus h. Here 0 plus h also this function exists, x not equal to 0. Limit h tending 0 h square sine 1 by h. This also 0 because sine 1 by h infinite value and 0 into something is 0. Now before we have to find this to show continuity, left hand limit and right hand limit. This 2 point we have also find in the adjustance of limit. Now next we have to at the given point for continuity 1 point also. At given point we have to check f of 0. When x is 0, function is defined 0, so f of 0 is 0. Therefore left hand limit equal to right hand limit equal to f of 0, and all are same value 0. Hence given function is continuous at x barabar 0. So for continuity we have find left hand limit, right hand limit and given point. All gives the same value, then this function will be continuous. If left hand limit equal to right hand limit but not equal to given point, then function will be discontinuous. If left hand limit equal to given point but not equal to right hand limit, then also function will be discontinuous. Now again, next question we discuss the continuity of f of x equal to mod x plus mod of x minus 1 in interval minus 1 to 2. Here at only one point we have to check 0, but this function is continuous or discontinuous in this interval minus 1 to 2. So at first we check first value at x बराबर minus 1. This is the closed interval. So minus 1 also exists, 2 also exists at x बराबर minus 1. Here left hand limit does not exist because this interval belongs to minus 1 to 2. So minus 1 minus something does not exist in this interval. So we find at this point f of minus 1. We get mod of minus 1, mod of minus 1, minus 1. So this will be positive, 1 plus 2, 3. Now, next, right hand limit. Limit h tends to 0, f of minus 1 plus h. Limit h tending 0, mod of minus 1 plus h plus minus 1 plus h minus 1. Limit h tending 0, mod of minus taking common 1 minus h plus minus taking common 2 minus h. So this will be limit h tends to 0, 1 minus h plus limit h tending 0, 2 minus h. We get 1 plus 2, that is 3. So here we have to find only two value, f of minus 1 and right hand limit, and both value are same. Right hand limit equal to f of minus 1 and this is equal to 3. So at this point minus 1, therefore f of x is continuous at x बराबर minus 1. Now next at x बराबर 2. Left hand limit here exists. 2 minus something belongs to this interval, but 2 plus something does not exist in this interval. So here for this point we have to find left hand limit. Limit h tending 0, f of 2 minus h, limit h tending 0, mod of 2 minus h plus mod of 2 minus h minus 1. Limit h tending 0, 2 minus h plus limit h tending 0, 1 minus h, and we get also value 3. And next point f of 2, mod of 2 plus mod of 2 minus 1, we get 2 plus 1, this is 3. Therefore left hand limit equal to f of 2 equal to 3. Hence fx is continuous in interval minus 1 to 2. So this function f of x is mod x plus mod of x minus 1 in interval minus 1 to 2 is continuous, because this point minus 1, this is continuous, this point 2, this is continuous. So this interval whole function is continuous to whole interval. Okay.